This is going to be an overview of the Chapter 2 lecture from the Probability and Statistics class. This lecture is very brief, so hopefully you will get through it without too much difficulty, and you'll be able to log into my math lab and knock out the homework rather quickly. First thing we talked about is the frequency distribution. Frequency distributions, there will be various types throughout the semester. So make sure that you are comfortable with reading the charts and the tables and so forth. So to help you along with that, I'm going to walk you through a couple of exercises. If you look at the first table, if I can find my highlighter here. If you look at the first table, we have IQ scores and then we have frequency within each range. Now notice we do not know the actual IQ scores. We only know the range of scores. For example, we have two students scored in the 50 to 69 range. Now, again, we do not know their actual scores. So we have a disadvantage in a way because we really do not know the raw data. We just have sort of a summary here. We have 33 students who scored in the 70 to 89 range, 35 students scored in the 90 to 109 range, 7 in the 110 to 129 range, and then 1 student scored in the 130 to 149 range. Okay, so again, we do not have the raw data. We just simply have sort of a distribution here that gives us the categories and how many scores are within each category. So let's look at number 1, part A. What are the lower class limits? Well, this exercise is just to familiarize yourself with how to interpret a chart. So when we're talking about lower class limits, okay, the lower class limits, the classes are each individual row. For example, the first class would be 50 to 69, the second class would be 70 to 89, and so on. So to determine the lower class limits, all we have to do really is to just look at these numbers at the lower end of each spectrum. I'll highlight these, and as you can see, the lower class limits would be 50, 70, 90, 110, and 130. So that takes care of part A. So moving on to part B, what are the upper class limits? Well, the upper class limits are just the opposite. So go back to each category and we will see that the upper class limit for the first row is 69, followed by 89 on the second row, 109 on the third row, 129, and then 149. So those would be the upper class limits. What about the class boundaries? The class boundaries, out of all of the problems from number 1, this one tends to cause students the most angst because it's not as straightforward, I guess. But here's what class boundaries are. Class boundaries help you during the rounding process. For example, if you had a student who scored a 49.5, well, if you round up, you would put them in the 50 to 69 range, right? If they had scored, let's say, a 49.4, then they would have to go into a lower range, which means we would actually have to create another row. So the question is, if you're addressing class boundaries, what's the cutoff? What's the cutoff score? So for the first row, the lower boundary would be actually 49.5, right? Because again, if someone scored 49.5, they would actually go into this top row, right? The 50 to 69 range. And again, if they had scored a 49.4, then we would probably have to create another row on top, right? And put them in that row. If we take 69 and 70, and average those two together, we would get 69.5, right? So 69.5 would be the second class boundary. And then if you take the 89 and the 90 and average those together, you would get 89.5. and so on, right? And then finally, if you look at the very top, the class boundary would be 149.5, right? Because if you scored anything, let's say you scored 149.49, right? Then you would end up in the 130 to 149 range here at the bottom. So that's how you find the class boundary for each row. And then class midpoints. Class midpoints, not too bad. Basically, it's like averaging 2 grades together. So how do you average 2 grades? Well, you simply add them up and then divide by 2, right? If you have 2 grades. And that's exactly what we do to find the class midpoint. So if you go back to row 1, on row number 1, we have 50 and 69. Well, the midpoint would be 50 plus 69. And once you figure out that total, simply divide by 2, and that will give you 59.5. On the second row, I have 70 through 89. So I'm going to take 70 plus 89. I'm going to figure out that total and then divide by 2. And that is going to give me 79.5. Third row, 90 plus 109. Figure out that total. Divide by 2. And you get 99.5. Row 4, 119.5. And then the last row, we would get 139.5. A word of caution here when using the calculator, make sure that you figure out the total before you divide. What I'm saying is this. Let's go back to the top row, 50 and through 69. Be careful with the calculator. If you type in 50 plus 69 divided by 2, you're going to get an incorrect response because the order of operations, the calculator follows the order of operations. So if you do 50 minus 69 divided by 2, it's going to divide the 69 by 2, okay? It's not going to divide the entire total. So a lot of times, if you know you're going to have to divide a string of numbers, I would put those in parentheses. It's a good habit. So you may say, you know, open parentheses, 50 plus 69, close parentheses, and then divide by 2. When you encapsulate the 50 and 69 in parentheses, it treats it as one number. So I would get in the habit of using parentheses anytime you know that you're going to have to divide a string of numbers. And finally, what is the class width? The class width is very simple. You can get it from any of the previous responses. If you go back and look at A, 1A, what's the difference between 50 and 70 or 70 and 90, right? The difference is 20. If you look at part B, what's the difference between 69 and 89? Well, again, 20. And 49.5 and 69.5, difference of 20. In other words, all of these data values, right, that we have figured out have a gap of 20 between them. Or you can just look, what I tell my classes is this, just look at the table, look at the lower class limits, and just subtract them. What's the difference? So take any of the upper ones and subtract the lower one, the immediate lower one, and that will give you the class width. Okay. Number 2. Whenever you hear, excuse me, whenever you hear relative frequency distribution, you know you're going to have to do percentages. You're going to have to do percentages. And I'm not sure exactly why I have the word cumulative there, but please ignore that. So let's look at the percentages. Well, to figure out the percentages, I need to know how many data values I have to begin with. So if we go back up to the chart, and if I take the 2 and the 33 and the 35 and the 7 and the 8, and I add those together, then I know that I actually have 78 IQ scores, right? I have 78 IQ scores, which means that I have 78 data values. Okay, so if you go back to the top, I know that I have 2 in the first row, 33 in the second row, 35, 7, and then finally 1. So let's get the percentages for each of these. So to get the 3%, all I did was I took the 2, right, and divided by 78. That gave me 0.03. And 0.03, and these are rounded, by the way. So I rounded to 0.03, which is 3%. And then I took the 33 and divided by 78 and got 42%. The solution for 35 divided by 78, 45%, and so on. Now I chose to round to 2 decimal places, and it served me well because if I total the percentages here, I get a total of 100%, which is what should happen in a perfect world. Now, if I had chosen to round, say, 1 decimal place, then I would have been way under, right? Because I didn't round high enough. And students always ask me, how far do you want us to round? Well, you have to follow the directions in My Math Lab. If My Math Lab tells you to round to 2 decimal places, then you would do that. If it says 4 decimal places, then obviously you would round to 4 decimal places. So just follow the directions throughout My Math Lab. For the most part, your tests are multiple choice, so rounding is not going to be an issue. And the last part of the lecture basically just consisted of a review of percentages. So number 1, if 92 people are surveyed and 18% say they are Democrats, then how many people surveyed are Democrats? So we know that 18% of the crowd identify themselves as Democrats. Well, how many people would that be in a crowd of 92? So think back to what your elementary teacher told you. When you hear the word of in mathematics, what do? Do you add, subtract, multiply, or divide? Right, you multiply. So basically the question is this: 18% of 92 would be how many people, right? So 0.18, that's the 18%, times 92 people, gives you 16.56 people. For this class, and for most statistics classes, whenever we are dealing with people, we always round up. So that would be 17 Democrats, right, in the crowd of 92. Number 2, a local kennel currently has 9 dogs, 3 cats, and 4 reptiles. What percentage of its patrons are mammals? Well, we know that dogs and cats are mammals. So I have 12 mammals at the kennel, right? But how many total animals are there? As far as we know, there are 16. We have 9 dogs, 3 cats, and 4 reptiles. So 12 out of 16 would be 75% being mammals. Number 3, what is 35% of to 12? Well, remember, of means multiply. And we need to convert the 35% to a decimal. So I take 0.35 times 212, and I get 74.2. Number 4, a slice on a pie chart reveals a sector that takes up 25% of its space. So if you look at the picture down below, it's a very crude circle. I apologize, but circles are not easy to draw freehand. But if you look at the circle, I marked off about 25% of it for the sake of argument. And let's say that that space represents a percentage of 800 people. So there are 800 people scattered evenly throughout the circle. How many would be in the 25% range? That upper right corner. Okay, so 25% of 800 would be 0.25 times 800, which gives me 200 people. So there would be 200 people situated in that slice area. That's pretty much all we talked about in lecture 2. I hope that you do not find it too difficult. If you do, please ask questions next week. Main thing is so far is to get involved in My Math Lab, right? You need to make sure you have your account set up and make sure that you are working the homework problems diligently, daily. I would say that for this class, you probably need to spend an hour a day minimum inside of my math lab, ideally more, and stay caught up. Do not get behind. So again, this wraps up the Chapter 2 lecture, and I will see you next time.